Hi, I made this video to help you understand better the method of using the conservation of mechanical energy to solve the mechanic problems. We are doing this problem again about the cyclist that we studied on last Saturday. A cyclist moving up a slope that has a constant gradient. This is the gradient of the slope, the incline that she climbs up. Okay, it takes her a second to climb up the slope, and given that the velocity, the speed of this cyclist decreases as a curve function like this. We have completed those questions above. The next one I want to do is about question C here. Show that the total energy converted into overcoming frictional forces approximately 670 joules. We know that the power of her cycling, of her what's it called, muscle. Her muscle does the work of 75 watts power. This is the work of the useful power, meaning the energy that she pushed the bicycle forward. The useful power, meaning that when we take this power 75 watts and multiply with the time 8 minutes, convert that into a second, not a minute, a second, we get the useful energy. That useful energy is 75 times 8, which is 600 joules. 600 joules. Okay. And that useful energy, 600 joules, will have three effects, three purposes. Firstly, to overcome the work done by resistive forces. And these resistive forces are the two forces. Firstly, we have this weight W, and it has a component, which is the red component here that I'm drawing, W1. This is one component of the resistive forces. Okay, and W1 here, you already know that is the weight times the sine of the angle alpha here of the slope, because that angle alpha is equal to this angle between the weight and the perpendicular direction here, sine of that angle. And the second resistive force is the frictional force Fr, also in this direction, in the same direction with W1. So there are the two resistive forces. Okay, so again, the useful energy 600 here has three purposes. Firstly, to overcome the work done by resistive force. Secondly, it is responsible for the change in kinetic energy of the system, meaning the bicycle and the rider, the cyclist. And lastly, to change the potential energy of the system. So we have the following equation: 600 joule for the useful energy is equal to the change in kinetic energy, which is 1/2 the mass. The mass of the system is 92 kilogram here. Yeah, and the final speed that we see here is 3 meters per second, and the initial speed here is 6 meters per second. So we can calculate the change in kinetic energy: 1/2 the mass, 92 kilogram, times the square of the final velocity, which is 3 square, and then minus the initial kinetic energy, which is half of 92 kilogram, and the square of the initial velocity, 6 meters per second. This is the change in kinetic energy. Next thing, the change in potential energy, mg delta h, where m is the mass, which is 92 kilogram, g we can take 9.8, and the change of the height, delta h, is calculated by the slope. We know that the angle, the slope, is climb up the slope. We don't know the height. We know the distance, Okay, delta H here, change in potential here. We already calculated that change in potential. The increase in the potential energy is 1170. Okay, put it here. So replacing the whole thing here by that value, 1170. And lastly, to overcome the work, overcoming the work done by resistive forces, that is the thing that we need to calculate, the work done by resistive forces. This resistive force is the sum of W1 and Fr, the friction. Okay, so this is the thing that we need to calculate. So that thing, let's call that W to simplify the problem, W. So that W of the resistive force is the number on the left here, subtract all of these things on the right. Okay, 600 minus 1/2, 92, 3 square, and minus 6 square. This is the change in kinetic energy. Subtract that thing and also subtract 1170. Okay, let me do the calculation again. 600 minus half of 92 kilogram times the square of 3 is 9, minus the square of 6 is 36, and then we might visit the difference between 600 and the change in kinetic energy, and then we subtract 1170 here, 1170 there, 672, exactly the same thing, almost the same, and we can round to 670 to 6 joule. So this is the work done by resistive force, meaning that total energy converted into overcoming frictional force. She does the work of 600 joule, meaning this value 600 is smaller than this one. The work done by the resistive force W1. So she has to take the energy from somewhere else. The decrease in kinetic. Okay, she can climb the slope because she had an initial kinetic energy 1/2 mv square, and this v square was initially 6 meters per second, and therefore due to inertia she can still move forward going up the slope, and her velocity is decreasing like a function like this, a curve, and the final velocity at the top of the slope is 3 meters per second, which is less than 6 meters per second, the initial velocity, meaning that the energy she had to use, 600 joule, can be smaller than the work done by the resistive force. In the case that she didn't have the initial kinetic energy, didn't have the initial velocity here, this amount of energy is not enough for her to go to the top of the slope. Okay, but because due to this initial kinetic energy, she was able to do that thanks to the help of inertia. Okay. The next thing, determine the average magnitude of frictional force. Frictional forces. So this frictional force is the sum of the friction and the W1, and we don't need to calculate frictions singly, solely, separately, but calculate this whole thing. The distance that she moved is 38.4 meters, and work done by this total force is 670, and therefore this whole force is 670 divided 38.4, which is approximately 17 Newton. I suppose 670 divided 38.4, yeah, 17.4 Newton. Okay, so that is the recap of the previous problem. Now we can move on to a similar problem. What is meant by work done? Use the formula: the force times the displacement in the direction of the force. Power is the rate of energy transfer, energy over time. So that the part of the fairground ride the carriage on the rail, the carriage and the passengers have the total mass 600 kilograms. The carriage is traveling at a speed of 9.5 meters per second towards the slope inclined 30 degrees to the horizontal. The carriage comes to rest after traveling up the slope to the vertical height 4.1 meters. Calculate the kinetic energy of the carriage and the passenger as they travel toward the slope, meaning the initial kinetic energy. That is a very simple question. Just need to use the formula: 1/2 of the mass times the square velocity the mass is 600 kilogram total, 1/2 of that, and times the speed 9.5 square, and you will get the answer, which is 27 kilojoule approximately. Okay, 27 kilojoule. That kilo, not just joule. Okay, meaning it's approximately 27,000 joule. So that the gain in potential energy to carriage potential is 24 kilojoule. Easy also. mg delta h. Delta h is the increase in the height, which was given 4.1 meter. The g is 9.8 and the mass is 600. And then you get this value, 24 kilojoule. Calculate the work done against the resistive force as the carriage moves up the slope. Basically, this question is very similar to the one that we've done. Okay, against resistive force. So the useful work, we don't have that thing, meaning this system goes up the slope by its own inertia, without the push of the engine, without a driving force. So this kinetic energy 1/2 mv square will convert into the potential energy mg delta h, and the difference between the two things, there's some energy loss. We say energy loss is equal to the work done by the resistive force. So basically that difference, the work done by the resistive force, is the difference between kinetic energy and the increase of the potential energy mg delta h, which is 27 kilojoule minus 24 kilojoule. Okay, and that is 3 kilojoule, 3.0. Check that. Yeah, that's it. Use your answer to calculate the resistive force acting against the carriage as it moves up the slope. Again, easy. We need to calculate the distance that it travels up the slope. We are given that this distance, the height, the increase of height is 4.1, the angle 30. So the distance that the carriage travels up here, s, is 4.1 over the sine of 30 degree, right? Because we have sine of 30 degree is equal to the opposite, which is 4.1, over the hypotenuse, which is s that we need to find, and therefore s is this ratio. And okay, calculate that one also. 4.1. The sine of 30 degree is half, 1/2, meaning 0.5. 30 degree here, and take the sine. Okay, that's it. And therefore that distance that the carriage travel is 8.2 meter. 8.2 meter. So just plug in here. The work done by resistive force is 3 kilojoule, which is 3000 joule. That equal to the resistive force that we have to calculate now, times the distance s, and that distance s we have just calculated is 8.2, and therefore this resistive force is calculated as 366. Just take 3000 divide 8.2 here, 366 Newton. Okay, that is another example. Thank you.